Many devices around us rely on motors. Just press a switch and they start to rotate. But how does a motor actually work? Let's break it down. 1. Magnets and poles. We all know that magnets have an N pole, north, and an S pole, south. Opposite poles attract each other while like poles repel. Imagine a magnet with a hole drilled in the center. The shaft magnet can rotate around this hole. Bring another magnet close to it, and the magnets will immediately rotate until their opposite poles align. 2. Switching magnets. By switching the magnets, the other side of the magnet will continue to rotate. If we keep switching the poles of the right magnet, it will continue rotating. Understanding this concept of magnet rotation is crucial for comprehending motor operation. 3. Electromagnets. Now, let's introduce electromagnets. These are magnets created by passing an electric current through a coil of wire. When powered on, an electromagnet becomes magnetic. When off, it loses its magnetism. By flipping the battery or using switching wires, we can change the polarity of the electromagnet. 4. The commutator. Replace the rotating magnet with an electromagnet. As the wire switches the poles of the electromagnet, it will rotate. To enhance magnetic force, place a magnet on the other side. The middle electromagnet now rotates. To create a motor, the curved magnets on both sides become part of the motor, and the winding bolt in the middle forms the armature connected to wires. 5. Adding a commutator. Manually switching wires to keep the armature rotating is cumbersome. Enter the commutator, a circular device with symmetrical gaps. As the armature rotates, brushes on both sides connect to the circuit. Springs inside the brushes maintain contact with the commutator. When a brush passes through a gap, it switches the contact point, reversing the current. This keeps the armature rotating. 6. Continuous rotation. Split the commutator ring and add another loop. Now, as the brush touches a circuit, the electronic body starts working and rotates due to magnetic force. Switching to the next circuit opens a new electronic path, and the brush continues switching. This allows the motor to rotate continuously. By adding more circuits, we achieve smooth, continuous motor rotation. 7. Motor components. The fixed part of the motor is called the stator, not nail. The stator houses the curved magnets on both sides. The middle part, the rotor, contains the winding bolt, armature. The drive shaft passes through the rotor, allowing it to drive various devices. And there you have it, the basic working principle of a motor. From children's toys to room cooling fans, motors power our everyday lives.